I got two of you. Let's see who else we get. All right. We're missing Monica and Javier. But we'll go ahead and get started. Now, is everybody getting their notes filled in? Okay, for chapter 8? Are you all muted? Yes. Everybody's got them? Yes? No.
Yeah.
All right. You all actually can see you. You know, if you're doing that and I can't see you, it doesn't. All right. So what we're working on, yesterday we did section 8.3. Oh, thank you, Michael. That works too. All right. What we did yesterday working on 8.3 was talking about arc measure and arc length. And that dealt with central angles and their arcs were congruent. They had the same measure. Central angles had this vertex at the center. The ones that we're working on today, is on your section 8.4 notes, are called inscribed angles, where the angle's not, the vertex is not at the center, it's actually on the circle. So this is an inscribed angle. Angle XZY is inscribed because its vertex is on the circle. So those are the ones that we're going to be working on today in section 8.4. Hopefully you can read behind me what we're going to be doing. On pages 372 and 373, we're doing 1 through 16, and then 18 through 28 even. So it's still not, I mean, it's a lot of problems, but it's not as much as what we did when y'all were here. I'm trying to cut stuff down, make it a little bit easier since we're having to do it online. So everybody needs to make sure they have their book ready, to write with, and we've got our book open to page 372. Oh, there's some. Why do we have 2 page rows? Nobody needs 2 page rows.
It's because he's trying to figure out how to use it on his computer.
Oh.
But he has to update some stuff on it.
Okay.
So he's doing it on his phone and his computer.
Okay. Oh, there's Monica. Okay. All right. So the only one we're missing is Javier.
Yeah.
All right. Okay. Yeah, Kaya made it today. All right. So we're on section 8.4, 372, and you know I can't see this little print in my book. So for the first ones, we're using this first picture that I drew up here, plus you have it there in your book. I'm going to move where y'all can, hopefully y'all can see the board pretty well. I know I've got a little bit of the reflection. I'll kind of move to avoid that when we get to that part. We have the circle drawn. W is the center of the circle. You have X, Y, and Z that are actually points on the circle. So we're going to use that picture for questions 1 through 5. So we're on page 372 and we're looking at 1 through 5. On number 1, it says, what type of angle is angle W? Angle W is there at the center, so it's going to be a what type of angle? Central angle. So that's all you're doing right there. Okay. Number 2 says, what type of angle is angle Z? Now remember, this is the new definition, which you had it in your notes for section 8.4. If the vertex is on the circle and its 2 sides of the angles are chords, it's called an inscribed angle. Okay. Number 3, find the measure of angle W and the measure of angle Z if arc XY is equal to 86 degrees. So if this is 86 degrees, we're going to find the measure of angle W and the measure of angle Z. Now, the measure of angle W is what we did yesterday. It was a central angle. The angle and its arc are equal to each other or congruent, the same measure. So if the arc is 86, the central angle is 86 degrees. For the inscribed angle, the new definition that you had today if you had read in your notes or in the section 8.4, an inscribed angle is equal to half the measure. Okay? The side angle is equal to half the measure. So when you are doing that, okay, when it's equal to half the measure, you're taking 86 divided by 2, so you're going to get 43 degrees. And that's it. Okay, so if it's the central angle, it's equal to the arc. If it's the inscribed angle, it's half the arc. So that's the part you got to remember. Now on number 4, it wants to know the measure of angle W and the measure of angle Z, but it gave us different criteria. On this one, it said arc XZY was 278 degrees. So this isn't 86 anymore. From here, all the way around the circle to there was 278 degrees. Okay, so if I want to know angle W, what's an entire circle equal to? Everybody remember that? The entire circle was equal to 360 degrees. So if I want to know this part, the rest of it was 278. I know the rest of it was 278. Then I just take 360 minus 278 to find the missing angle. You have calculator, you do calculator, or you have to use your brain.
82.
He says 82. So if angle W is 82, that means this was 82. So angle Z, remember, is half of that, so it would be 41 degrees. So I'm trying to move where you can see there, where the light's not across there. So the measure of angle W is 82 degrees, and the measure of angle Z is 41. Okay, and then for number 5, it said find the measure of arc XY. So on this one, we're looking for XY. If the measure of angle Z and the measure of angle Z, whoops, can't read. If the measure of angle W is D degrees. Okay, now D degrees is kind of weird. So since we have a variable, are we going to get a number? We're not going to get a numbered answer on this. I'm just erasing that stuff off so that way. We're not going to get a numbered answer on this, but we know whatever angle W is, arc XY is the same thing. So if this is the measure of angle W is also going to be, I mean, if measure of angle W is D, then arc XY was also equal to D. Okay, and then for the measure of angle Z, if this is D, remember the inscribed angle is equal to half of its arc, so it would be half of D. That's what you're gonna have for that one. Y'all can see it, it's not cooperating. I'm trying to get rid of the lights off the thing. So for measurement, arc XY is D, angle Z is half D. Okay. Now for the next ones, for 6 through 14, we're using this picture. For this picture here, you have a bunch of chords. None of them are diameter because none of them pass through the center O. Okay, so none of them are diameter. They're just chords. And so you have a bunch of inscribed angles, and they have the inscribed angles numbered there. Okay, so what we're going to do on here, it says if DC is equal to 60, find the measure of angle 4. So DC is this arc here. If it's 60, angle 4 is the inscribed angle. So half of 60 is 30. So it's just 30 degrees. And that's all you do. The inscribed angle is equal to half of its arc. On number 7, it says the measure of angle 1, which is right here, is 40 degrees. It wants to know the measure of arc AB. So if the angle is 40 and I want to know the arc, I do the opposite. Instead of taking half of it, I multiply it by 2. So measure of arc AB will be 80 degrees. Oh, look who finally said show up. All right. Okay. So we got that. Inscribed angle is half the arc. I've got the angle. I multiply by 2 to get the arc. That's what we're doing. Number 8. If the measure of angle 3 is 25, so the angle is 25, to find arc DC, I multiply it by 2 and get 50 degrees. Javier, we're on page 372. Okay. Number 9, we're looking for it says arc AB is equal to 130. So the arc is 130 degrees and it wants angle 2. So to find the measure of angle 2, I take half of 130 and get 65 degrees. Number 10, it says if measure of angle 3 is 28, find the measure of angle 4. So now if you look closely at this one, angle 3 is right here. So this arc is twice that, but that's the same arc that angle 4 intercepts. So angle 3 and angle 4 then are going to have to be congruent. So if angle 3 was 47 degrees, wait, that's not right. I'm looking at the wrong one. If angle 3 was 28 degrees, measure of angle 4 is also 28 degrees. If they intercept the same arc, then they're going to be congruent. So angle 3 is going to always be congruent to angle 4 in this picture. Angle 1 is always going to be congruent to angle 2 in this picture. Okay. Let me see. Okay, I'm going to unmute everybody for a minute. Okay. So everybody got 1 through 10. I'll try to make this a little bit where Javier can get the answers we've already done. Okay, but everybody should have 1 through 10. So is this hard? Isn't that bad, is it? All right. So we're doing the same thing on 11, 12, 13, 14. Chips. All right, on number 11, it says measure of angle 3 is 47. You're finding the arc DC. So if I go to the angle and I'm trying to find the arc it intercepts, I multiply it by 2. So 47 times 2 is going to be 94 degrees. If you've got the angle, you multiply by 2 to get the arc. If you have the arc, you divide by 2 to get the angle. Number 12. If measure of angle 4 is 30, so this is 30, it wants to know the measure of arc DBC. So DBC is from here all the way around to here. So I'm not looking for DC, I'm looking for the rest of the way around the circle. But if I know this angle, I can find this arc, and then I can subtract it from 360, because that's what an entire circle equals. So angle B, it said, was no, angle 4 was 30 degrees. So if this is 30 degrees, 30 times 2, this is 60. So then take 360 minus 60.
300.
The measure of arc DBC is 300 degrees. Okay. And then number 13. On number 13, we're looking for the measure of angle ADB. So ADB is going around the other direction. It's going from A through point D all the way around to B. So I'm going around that way. And it says on 13, measure of angle ABD was 290. So if that's 290, how would I find this part here? What does an entire circle equal?
360.
So I take 360 minus 290 and get 70 degrees. So if this is 70, then angle 1 is going to be half of that. Measure of angle 1 is going to be 35 degrees. And that's what it wanted you to find in number 13. Okay. And then on 14, it told you the measure of angle 4 was 40. So this little angle inside here is 40 degrees. And it wants to know the measure of angle CAD. So CAD is this way around the circle. So it's everything but DC. Well, if this is 40, DC will be 80. So then you take 360 minus 80 and get the measure of angle CAD.
280.
Minus 80 is going to be what?
80.
280? Is that what I heard? Yep.
That's what.
Okay. So everybody's getting 1 through 14 written down, yes? You're good with that? Okay, now for the next one, it's a word problem, your all's favorite. Okay. We're still doing the same thing. Okay, everybody needs to have their book open so they can actually look at the picture because I'm not drawing the picture up here. It's on page 372 down at the bottom. It says, assume that this stone semicircle in Peru has a radius of 21 feet and that the measure of angle A is 5 degrees. Okay. So the radius is 21 feet and the measure of angle A is 5 degrees. So first it wants to know the measure of arc CD. So you got to look at your picture. The measure of arc CD. I'll move the camera just a minute. I was trying to give people time to make sure they 1 through 14. The measure of arc CD. Angle A is the inscribed angle for CD. So I take the angle, measure it, and multiply it by 2. So CD is going to be 10 degrees. The angle A was 5 degrees. The arc that it intercepts is going to be 10 degrees. And on part B, it wants to know the measure of angle B. This is like what I talked about up here. We said angle 3 and angle 4 are always going to be congruent because they are inscribed angles of the same arc. They both intercept the same arc, so they've got to be the same measure. So for angle B intercepts this same arc, so it's going to be the same as angle A was. It's going to be 5 degrees. And then the last part says, estimate the length of the stone intercepted by the angles by finding the length of arc CD. So arc length is what we did yesterday. arc length, remember our formula was L equals the angle over 360 times 2 times pi times r. So you had your angle over 360 times your circumference of the circle. So our angle is going to be the measurement of RTD, which was 10, correct? So I have 10 over 360, this is for part C, times 2 times pi times the radius, and they said the radius was
21.
Is that correct?
Yeah, 21.
Okay. So I have that there. Okay. So when we look at this, I can go ahead and multiply 2 times 21 if I want to make it a little bit easier. So I have 10 over 360 times 42 pi. Okay, and then I look for things that I can copy from yesterday. Okay, so there is. All right. So when I go to do this, I can simplify 10 over 360 first. That cancels, so I have 1 over 36. And then what is something that divides into 36 and 42? We can divide them both by 6. Okay. 42 divided by 6 is 7. 36 divided by 6 is 6. So my length will be 7 pi over 6. And I believe it was feet, so you always put your units of measure on your answer. Now, if you had the calculator and you wanted to try to divide it out and get a decimal and round it off, you could, but it's just as easy. Leave it like that and you're done. Okay. Everybody got that? Yes? Number 15. All right. Flip the page. We're now on page 373. On page 373, number 16 is your all's favorite. It's a proof. I see some of your all's faces. Okay. So it's a proof. It's already set up for us. We just have to fill in the blanks. And then on the last part, on 18 through 28, we're just doing the evens. So what I would actually like to do is do the even problems first, because these are actually problems where we're still doing the measures. And then we'll go back and do the proof at the end and be done. Okay, so we're skipping to number 18 right now. So everybody's on page 373, number 18. That's where we're at. Okay. 373, number 18. So on number 18, it says if the measure of angle LOM equals 82 degrees, find the measure of arc MNL. So this is what I was talking about earlier. You have to look at the picture, and I'm not drawing the entire picture. I'm just doing part of it up here. So you have M is here, you have L is here, and you have O is down here. I'm just drawing the part that we're talking about. Okay, it said angle LOM was 82 degrees. It wants to know the measure of M and N's down here, of M and L. That's the arc going all the way around the circle, almost. Okay, so what we do first is if we got the angle, we can find this arc by multiplying by 2. So you have 82 times 2 for this portion up here, and you get 164. That's from between M and L. You have to find going around the opposite direction, so you take 360 minus 164 to get that answer. And so it's going to be measure of angle, arc, not angle. Measure of arc, MNL. It's going to be 196 degrees. You have to take the angle, double it to find this arc, and then subtract from 360 to find the rest of it. Okay? So,
Okay.
for what? Yes? You got it? Number 20. For number 20, it says if MN equals LO, so you have the two side arcs are congruent, and they both equal 130 degrees, find the measure of angle MYL. Okay, so I have the circle, I have M and O and L. I'm not drawing the whole thing, but it said this was 130 degrees and this was 130 degrees. Okay, that's what it said. Okay, now the next part said that we're looking for MYL. MYL is in here. That's this angle here in the center. Okay, right? Am I looking at the right one? Yeah. All right, so what we've got, if this is 130 and this is 130, what's the whole circle equal? Or do we want to just find out what this angle down here is equal to?
Equals 160.
Here is equal to. What's half of 130? I wrote it on the board.
Oh, 65.
Half of 130 is 65. So to find this angle in here, we've got two of those because it makes a triangle. And the whole, what's a whole triangle equal to?
180. No.
Basically, you have a triangle inside of here. I just didn't draw very good at all. But you have a triangle inside here. That's just ugly. All right. So triangle equals 180. So I have 180 minus 2 times the
65.
65, and that's going to give me my angle that I need. So 2 times 65 we know was
13.
130.
Oh.
180 minus 130 is 50.
50.
So the angle that it wanted was 50 because it makes a triangle inside there. I just didn't draw it well at all on my picture. So for you. Number 22 is looking at a different picture, so maybe I'll do better on that one. All right, so number 22 has a bunch of parts. Okay, we got A, we got B, we got C, we got D. Okay, 22 has A, B, C, and D. On 22, for arc EF, you look at it, you look at what angle it intercepts. Okay, the little angle that it intercepts at H was 31 degrees, so EF will be twice of 31, which is 62 degrees. Y'all answer, okay? So let's look at B. Arc DH. DH over there is 6. We're looking for DH over on the side. What's D equal to? Look at DH. Follow the sides across to find the angle it intercepts. I'm not drawing the picture up here. Well, there's no need for that much background noise if you're just following along doing these problems. But I want to keep you unmuted. I want you all to listen and participate.
31.
It didn't sound like you're throwing everything across your room. All right. So on here, for DH, I just highlighted those two sides. The angle that it goes to is over here. So you got to look at your picture in your book. What's the measure of this angle in your book?
49.
49 degrees. To find the measure of the arc D, I take 49 and I multiply that by 2. So it's 90 degrees. And you just look at the picture. This on the arc that you're talking about. Arc E. Arc E and from arc E to G.
Is it 31?
Part is 48 down here. Okay. Here was 62. That's what we did in part A. So if I wanted to do the whole thing, what are those two numbers? What do I do with those two numbers? We add them together. So 62 plus 48 is going to be 110 degrees. And then for GH, GH is the little small part down at the bottom. So to find GH, what we're going to have to do is we're going to have to take all of them we've already found and subtract it from the entire circle, which is 360 degrees. Okay, we know this part was 48. We know this part was 62. On our picture, it told us this part here was 94. We found DH from here to here was 98, and we're looking for the piece down here. So what you're going to do is take all of these, you're going to add them together, and then subtract it from the 360 degrees. So I've got 360 minus 98 plus 94 plus 62 plus 48. So you have to add all those together and then subtract it from 360.
Okay. 98 minus plus 94. 466.
How can you end up with more than what the whole circle is equal to?
Oh.
$58. Okay, 58 sounds much better. Thank you. You add all these together. These two added together is like 192. These two added together is like 110, and then you subtract it from the 360, so you get 58 degrees. Okay, because your entire circle always adds to equal 360. Okay, so let's go ahead and do 24, 26, 28, and then we'll go back and finish our proof. So on 24, it says find the measure of angle RQT. Angle RQT. So if you look, R and T are endpoints of a diameter. So if you had actually filled your notes in, a diameter splits the circle into two what? What's half of the circle called? Half of a circle is called a semicircle. All this is on the notes and those theorems and definitions. Okay, so RT is a diameter. So if I'm looking at angle RQT, I'm just looking at that part of the circle. So here's R, here's T. Okay, so you have a line that goes across there, and then you have Q's over here. Okay, so RQT intercepts a semicircle. So remember, your inscribed angle is equal to half of the arc. Half of a circle is going to be how many degrees? Half of a circle is going to be 180 degrees. So half of the circle, measure of angle RQT is going to be 90. Half of 180 is 90. When you have an inscribed angle intercepting a semicircle, it's going to be a right angle. That was one of your theorems that you had on your notes for section 8.4. Number 26, finding the measure of RS and the measure of angle SQR. So we're finding RS and SQR. So we have our picture. If I got everything on there. Okay. So this is RSQT. Okay. So this is our picture. Okay. So for number 26, it said that this angle down here was 42 degrees on your picture. And it wants to know the measure of RS, this arc, and then it wants to know the measure of angle SQR, that angle right there. Okay, so my arc is this arc up here intercepted by this inscribed angle. So I take the angle and multiply it by 2 to get the measure of arc. So RS is going to be equal to 2 times 42, or 84 degrees. Okay, so this arc is 84 degrees. Now you look at the other part of the question. It wanted to know the measure of angle. Did they put R or S first? SQR. Okay, so here's angle SQR. It intercepts, it cuts off of the circle the same arc, R and S. So it's going to be the same measure as this because it's going to be half of the arc. So half of 84 was 42 degrees. So a lot of times you feel like you're going back and forth the same thing, but it's using different parts of the circle. And then 28, if the measure of QS, I'm going to erase that. If the measure of QS, so from Q around S was 142 degrees, find the measure of RSQ, that angle there, and RUS, that angle there. Okay? So what we're going to start with for number 28 is this arc is 142 degrees. I only want to know this angle. This angle intercepts this part of that arc. So that's only this little piece. We already said this was 42, so this part was equal to 84. So to find this part, I would take 142 minus 84. So 142 minus 84. What do you get?
58.
58. Okay, so this arc piece is 58 degrees. So if this arc is 58 degrees, its inscribed angle, which was the measure of angle RSQ, which was the first one it wanted, is going to be half of that. So half of 58 is equal to 29 degrees. Okay, so that's my first thing. That's my first measurement. This one we found was 29 degrees. Now, it wants to know the measure of what? RUS? Yeah.
Mhm.
Now remember, we said RT passed through the center of the circle, which means it divided the circle into half, 180 degrees. So this whole half of the circle is 180 degrees. So if this part's 84, I can find this part. Take 180 minus 84, so this part's gonna be
96.
96. So if this part's 96, this angle right here that it intercepts, okay, see the inscribed angle for this arc is going to be half of that. So half of 96 is
Mhm.
48 degrees. Are we done yet though?
No.
No, we're still not done because that was 48 degrees. But is that the angle that it wanted? No. The angle it wanted was angle RUS. To find the measure of angle RUS, we know that the angles in a triangle always add to equal 180 degrees. So we have, this one was 29, this one was 48. So we can find this one now because we can add and subtract from 180. So it's 180 minus 48 plus 29. So you add those two together first. 48 and 29 is
77.
77. And then you subtract 180 minus 77 and get
103.
103 for angle RUS. Okay. So that's all of the problem ones. Okay. So the only thing left is we need to fill in our proof real quick. Okay. So what always goes in your first statement of a proof?
Reason.
The given. It gave you the reason was given. So up there, you see in the problem, it says given circle K with K in the interior of inscribed angle ABC. So you just copy down what it said for the given in the first blank. So everybody should be able to handle that one on their own. You can write it down. Now, for number 3 statement, it said they did it for the reason to as angle addition postulate. So you know it's going to show angles being added together. So for number 3, this is on 16. For number 3 statement, you're going to put measure of angle ABC is equal to measure of angle ABD, and I'll move the camera over in a minute, plus measure of angle DBC. You show that they're added together. Okay. That's your first one because it said it's by angle addition. Then number 4, the reason was case 1 of the inscribed angle theorem. Case 1 says that if you've got the inscribed angle, it's equal to half of its arc. So what we can say is we can say that the measure of angle ABD is equal to half of the arc it describes, intercepts, which is AD. And we can say measure of angle DBC is equal to half of the arc that it intercepts, which is marked arc DC. Because the inscribed angle is equal to half of the measure of the arc that it intercepts. Now you'll notice ABD was this angle that I had added here. DBC was the angle that I had added here. So what we're going to do next is you'll notice they've changed it and put measure of angle ABC equals half of measure arc AD and half measure arc DC. So the reason for that is Substitution. They took what we said they were equal to here and plugged it in. It was substitution. Okay, for number 6, you'll notice that in here they had half in both of them. So what they did is they took measure of angle ABC is equal to 1/2. They just moved the 1/2 out front. Measure of arc AD plus measure of arc BC. Because they said they did distributive property. They took what they had in common and put it out front in front of the parentheses. Now, for number 7, they're saying that the measure of arc AD plus the measure of arc DC, that's the 2 arcs added here, are going to be equal to the measure of arc AC. Because the 2 smaller arcs add to equal the whole thing. And the reason for that is arc addition postulate. And then for number 8, they just said measure of angle ABC was equal to half the measure of this, and they did that by substitution again. That just looks really ugly, but that's what it is. Substitution again. Okay. All right. Okay, so I'm going to unmute you all for a minute. So, down if you can't, then everybody got 16. You see where all you had to do was write these in the blanks. Okay?
Yes.
So everybody should have today's done. You should have had yesterday's done. Tomorrow, I'm going to do at the beginning of class is I'm going to spotlight you all individually so you can show me your book or your notebook, whatever you work in. So you had these done. And we're going to review these 2 sections so we can get ready for a quiz over section 8.3 and 8.4. Okay. Question on any of these?
I got a question.
Yes.
What was the homework? Did y'all have homework yesterday?
No, we just did what we did in class. And what I'll do, because you couldn't get logged in yesterday, right? You lost your internet or something. Is I'll try to send you an email later that has the link to what we did yesterday, so then you can get those problems out for section 8.3. Okay? But I'll email you the link to the video from yesterday so you can get the answers from yesterday's. Because we did section 8.3. I think we did what, 1 through 23? I think that sounds right. So I'll send you the video link for that in the email so you can get that. Okay. Any other questions on there? All good? Ready to have lunch? Some of you all probably didn't even have breakfast till like 20 minutes ago because y'all don't get up. But anyway, when do you all start class? What's your first one? When do you all have to log in first?
Oh, 9.
At 9? Okay.
Yeah.
Okay, so, but you're done now, right? Except for your FLVS?
Yeah.
Okay. So see, I'll email Kaya the link to the recording from yesterday. Everybody else, make sure you have your book ready first thing tomorrow and log in on time. Not 15 minutes late, Javier. You already left. It's his grade. Be here for class just like you're expected to be here for class online. Okay?
Okay.
Having it here on time, you gotta be on time online. At 11.
Yes, ma'am.
Yes, ma'am.
Monica, were you good with chemistry?
Okay. Yes.
Yeah.
All right. I'll see all of y'all tomorrow then.